Okay, in this video we're going to be solving the system of equations below. So for this system, the first step we're going to do for substitution is to get one of the variables by itself in one of the equations. There is some advice to do before that. So for instance, for this first equation, I would not want to get x by itself. The reason why I wouldn't want to do that is because the other equation has x squared. That makes the process a lot longer to deal with. So if possible, I would like to avoid that. Also, in the second equation, because there is both x squared and x, it's not really advisable to get x by itself in that equation. So in both cases, getting x by itself is not really advisable. So we're going to get y by itself, and it doesn't matter which equation you do that with. I'm just going to choose the linear equation. So I'll move it off to the side here. I'm going to try to get y by itself, and to do that, I will subtract x from both sides. We can't actually combine the 5 and the x, so it stays 5 minus x. And now we have an equation with y by itself, so we're going to put it in a box to store it for later. Now, second step is to go to the other equation, which is here, and we shall replace y with what the first equation said y equals. So I'm going to replace y with 5 minus x. Plus 1 will come down, and so will everything on the other side of the equal sign. Now, I did put the 5 minus x in parentheses. That's not really necessary in this case because there's nothing connected to y by multiplication. So now we just have to solve this equation. That was step 2, just setting up. Step 3 is to solve the equation. So I'm going to combine like terms first. So 5 plus 1 is 6. So we have 6 minus x equals 3x squared plus 2x. Next thing, we need to get everything to one side because we are solving a quadratic. So we need to equal to 0. So I will be subtracting 6 and adding x to both sides, which cancels out everything on the left side. Makes it 3x squared plus 3x minus 6. From here, we can either use zero product property and factor, or we can use quadratic formula. I know that most of my students have been using quadratic formula, so that's what I'm going to use here. But factoring works as well, so if you remember factoring, you can also use factoring. So quadratic formula, a is 3, b is 3, and c is negative 6. If you fill it into the quadratic formula, we will have negative b plus or minus the square root of b squared minus 4 times a, which is 3, times c, which is negative 6, all over 2 times a, which is 3. When I do quadratic formula, I always do 3 things to simplify. I deal with this. So negative 3 is just negative 3, plus or minus the square root of. Second thing I'll do is I'll type this stuff underneath the radical into a calculator. So we have 3 squared minus 4 times 3 times negative 6. Which gives me 81. Oops, forgot to change back. And the third thing I deal with is the multiplication on the bottom. 2 times 3 is 6. Now, the square root of 81 is a perfect square, so that's great. Saves a lot of trouble. So negative 3 plus or minus the square root of 81 is 9 over 6. It's a perfect square, so we'll separate it into the two cases. Negative 3 plus 9 divided by 6. Negative 3 minus 9 divided by 6. Negative 3 plus 9 is 6, and 6 divided by 6 is 1. Negative 3 minus 9 is negative 12. Negative 12 divided by 6 is negative 2. So overall, our two x values are x equals 1 and x equals negative 2. Now, don't think you're done just yet. This was only step 3. We are solving a system. So all of this here is step 3. All step 3. For a system, you need both x and y. So that for the final step, we're going to go back up to the equation from earlier that I put in the box. And I'll plug my x values back in. So we have two x values. So we're going to do this twice for step 4. My first x value is 1. So 5 minus 1 is 4. So the first answer is 1, 4. And our second answer, so 5 minus negative 2. Double negative makes a positive, so it's really 5 plus 2, which is 7. So my second answer is negative 2, 7. And there are my two answers for this system. Okay, so we're going to solve the system of equations below. Now, we're going to do it by substitution here. And the first step with substitution is typically to get one of the equations with one of the variables by itself. But I want to point out here, the second equation. Now, y is not technically by itself because we still have y squared. However, the reason why we normally have that as our first step is because most of the time we deal with linear equations for systems. You don't technically have to have y by itself. So long as whatever you have by itself is in the other equation, you can replace it. In this case, we have y squared in the other equation. So I actually don't have to get y completely by itself. It looks a little bit different doing it like this, but we can do it like this. So what's happening now? Step 1, we're going to use y squared equals x plus 5 for our equation with y by itself. Not completely by itself, mind you. But what this equation does is it tells us we can replace not y, but y squared with x plus 5. So I'm going to be replacing y squared here with x plus 5. So we have x squared plus x plus 5. The parentheses aren't really necessary here because there's nothing connected by multiplication. But if that was a subtraction sign before it, I would definitely need parentheses. But equal to my 25. So there's the setup. And that is step 2. Step 3 now is to solve the quadratic. So I'm going to basically ignore the parentheses. And then get it equal to 0. So subtract 25 from both sides. Give me x squared plus x minus 20 equals 0. So since I did the first example with quadratic formula, I'm going to do this example by factoring here. So I'm going to multiply first and last. giving me negative 20 x squared. And then after I do that, I need the combination of factors that add up to be positive 1x, because a number in the middle is implied to be 1. So 1 and 20, 2 and 10, and 4 and 5 are the combinations. We need a positive 1, so the combination we're going to need is negative 4 and positive 5. Since there is no leading coefficient, we can skip over the extra steps for the factoring by grouping and jump straight to the factors. The factors will be x minus 4 and x plus 5. And again, you can do that anytime you are missing the leading coefficient, or the leading coefficient is 1. Now we're not quite done because it's a solve, so we still need to get x by itself. So zero product property says when we have two things multiplied together, so each one equal to 0, and then just solve. So x equals 4, and x equals negative 5. And all of this would be step 3. Now we are doing a system here, so we still have a little bit more to do. Systems solutions are both x and y, so I need to go back and plug in the x's into one of my equations. I'm going to use the one that I had in a box. Now this is going to be a little bit different than some of the other ones we have done, mostly because we did not have y completely by itself. I'm going to start off by plugging the 4 in. So we're going to have y squared equals 4 plus 5. 4 plus 5 is 9. This time I have to make sure, because y was not by itself, I have to make sure to carry it down. And then to finish getting y by itself, we're going to square root both sides here. When I do that, I get y equals plus or minus 3, which means, because we can't have a plus or minus in an ordered pair, which means we actually get two y values with the x value of 4, meaning we have two separate ordered pairs. One of them with the x value of 4 as a positive 3 as the y value. The other one is 4 comma negative 3. Then, for the second equation, going through, or the second x value, we have y squared equals negative 5 is our x value for the second x value, plus 5. Negative 5 plus 5 is 0. And then square root both sides. We have y equals plus or minus the square root of 0, which is 0. And both positive 0 and negative 0 are the same thing, so it's really just y equals 0. So our third solution is negative 5 comma 0. Now in this video, this one happens to not be a quadratic and linear. This is a quadratic and the graph of a circle. So the graph probably looks something like this, where you have it hitting in 3 spots. So, yeah, that's why we have 3 solutions, because the two graphs connect in 3 spots. And that's it.